Hello, students. This is Mrs. Robleski, and today I wanted to share with you how to take notes as a scientist. So many of you have been taking notes on several resources, and you're noticing that when you take a look at a science article like this one right here, that there's a lot of information that have headings, and there's usually, as a science article, has a lot of pictures and captions and drawings with more labels, and they usually give quite a few examples, or sometimes they include pictures to help illustrate some difficult science concepts. And so many times some of you are not sure, how do I put that into my notes? And it is important as a scientist, when you're looking at articles, to include those drawings, to include some of those pictures. So I'm going to show you how to go about doing that. So before I do that, I wanted to share with you that we have several students in the past who have used something called sketch notes. So they don't just take the notes that are on their resource, they also add some of those visual cues. It might be included in the article, or it might be something that you are adding, that you're thinking of from reading the article. And that really just results in making more connections and a deeper understanding. And looking back at your notes, it kind of makes more sense as you're going along. Lots of times it will boost your memory retention as well. And here is a former student sharing how she included visual notes in her resource. So here she is, a former student.
I'm Ava Kajowski, and I did the Water and Earth focus area for science. And it's about the water cycle and ocean currents. I use Cornell Notes because it helps me organize all the information I learn, and so I have my keywords and then my main notes in different places. I ended up drawing the pictures and writing notes down too because the pictures go with the notes and it shows where the evaporation and the precipitation happens, and then the notes kind of help show the steps of it, and then the picture just goes along with it to help me understand it better.
So do you always draw pictures?
It depends on if it seems like it needs one, because some things are well enough explained, but then other things a picture can be helpful just to see it. In this picture, it shows the water cycle, how water evaporates into the atmosphere, and it turns into water vapor, and then goes through condensation, and that's when it's in the process of turning into a liquid from a gas again. And precipitation is when water or sleep or snow, anything in that form comes back down onto Earth's surface. And then runoff is when it lands on land and flows back into the ocean or river body of water. It helps me understand what I wrote down in the information in the resource better. I take notes this way because it helps the way I think and can organize my thoughts.
So that's just another way of looking at an article in science and how can I make a better sense of my understandings when I'm looking at this article. So I'm going to go ahead and start looking at this article, and I would like for you to follow along. So you will need a piece of paper and you'll need a ruler to set up your Cornell notes, and we're going to go through this together. I'm going to have you pause the video in several places and kind of catch up and write down what I am writing down. So in the end, you will have a full resource completed. So I wanted to take a look at this one called elastic energy. We haven't really talked a lot about elastic energy, but we have spoke about some potential energy. And so when I'm looking at this, the first thing I'm going to do is start reading this. So I have elastic energy is energy stored in an object when there is a temporary strain on it, like in a coiled spring or in a stretched elastic band. So right away, they give me some examples. And I continue on to try to figure out, I don't have to write everything down. I'm trying to figure out what do I need to include to help myself better understand this. Because many times some of you are learning that they kind of repeat some concepts as you're going along. The energy is stored in the bonds between atoms. I'm not quite sure what that means, bonds between atoms. Maybe if I read on, they're going to explain that a little bit in more detail. The bonds absorb energy as they are put under stress and release the energy as they relax when the object returns to its original shape. So right away, I'm not going to necessarily write all that down. I'm going to continue on and see if there's something that explains some of those a little bit more. I do notice that there's a picture right off the bat, and there's something called a caption. And lots of times as students, we just kind of brush by that and go, oh, that's just a picture. Well, actually, there's some important information that goes in and is included in that picture. But I'm going to continue on and just look and see. I like how this article is set up where they have some headings. And a lot of times, many of you are looking at your Cornell notes and trying to pick out keywords. Keywords can also be headings or questions or something that is like the topic of that particular paragraph. So this one is called What is Elastic Energy? So I continue on. Elastic energy is a form. So right there, it's telling me a definition. And we know that definitions are important, but we also know that in science, examples are super important as well. So I'm going to continue on, but I do want to have some definitions. Because it is stored in the bonds between atoms. Again, there's that bonds between atoms. I might have to look that up a little bit more. In an object or substance when it's temporarily under stress. Oh, I just read that similar concept up here. This stress could be due to the object being stretched or squashed. So I think at this point I am going to start writing down some of my notes. So I need for you to have your paper out as well. And I'm going to kind of show us how we would do that. So we are going to start out with obviously putting the date. And then we would have the title. So our title here is Elastic Energy. This doesn't necessarily pertain to a focus area, so I'm just going to include just the resource at this time. And I set up my notes with the Cornell notes as I'm going along. And I noticed that that first thing that they had was the definition. So I'm going to write down elastic energy definition. And I'm just going to write the definition that they mentioned there. It's a form of potential energy because it is stored in bonds between atoms in an object when it is temporarily under stress. So you might want to pause your video because I'm going to continue on. You might want to pause your video and then unpause it after you have that written down. So I'm not quite sure what this bonds between atoms is. So I might have to look that up. Many times when you're looking at science concepts, they explain something and they explain it in a term that you're not familiar with. So I might have to go onto the internet and take a look at energy stored in bonds between atoms. So I go ahead and I type that in. And since I'm doing visual note taking, I might want to look at the images. So I clicked on images. So right away I clicked on images. I put energy stored in bonds between atoms. And I noticed that there were some pictures that didn't really help me, but I noticed that I've seen something like this before, like a molecule. So I clicked on that one, and over here it mentions that the energy is stored in the chemical bonds between atoms. And I noticed that there's some atoms here, but in between is super helpful. That's kind of that bond. And then I continue on and I look, oh, this one kind of seems helpful. So I click on this one. And it shows me that a bond is broken. And it mentions that when it's released, when the bonds break. So energy gets released when these bonds actually break. Now I have an understanding of what they're talking about when they say a bond between two atoms. But in the article, it didn't mention that. So sometimes I have to go beyond what the article has and include that. So I'm going to go back and mention that and draw that picture for myself so that I have a better understanding of that. So I go on and I go bonds between atoms. So maybe I'm going to just like right up here explain that so that when I look back at my notes later on, I understand what that means. So I have this atom picture. Okay. And it said that there was a bond between another atom and a bond between another atom. And then there was a smaller one and a smaller one. But I really should label. Pictures are not helpful because later on I'm not going to remember what that is. So I'm going to label this as an atom. And I'm going to label this right here. Energy is stored in these bonds. And it's released when they're broken too. I might even add that. But at least now when I'm looking at this word atoms and I'm looking at the word bonds, I have a visual that makes a little bit more sense. So when I get to a question or a word that I'm not sure of, I need to go and look beyond. It doesn't do me any good to just write down stored in bonds between atoms if I don't understand what that means. So it's super important to kind of stop, check yourself. What I just wrote, does that make sense to me? If not, I need to ask a teacher. I need to look it up. I need to ask a parent. I need to figure out what that means because it's not going to be helpful if I have it written down in my notes if I don't understand what that means. So I'm going to continue on then. And if you need to pause the video at any time to kind of get caught up, please do so. So I'm going to go back to my article. I already included what is elastic energy, and I mentioned that. And then I noticed that it said something right here. It says stretched or squashed. That was a really important example that I have. And then there's this picture, and I can see that she's actually stretching the bow and arrow. And it mentions right here that the elastic potential energy of the bowstring transfers to the arrow as kinetic energy. Now, I already know from a previous resource what kinetic energy is, but if I didn't, again, I'd have to go look that up because it wouldn't be helpful for me to just write that information down and not know what kinetic energy. Luckily, I do have a resource, and then I know from before that kinetic energy is that movement energy, and yes, the arrow would be moving. So how do I incorporate that into my Cornell notes? So I'm going to go back to my notes here. And instead of writing the elastic energy definition, I'm going to write elastic energy examples and a labeled drawing. Notice I did not just say drawing. I said a labeled drawing because it's helpful to label it instead of just drawing a bow and arrow. There was some information in that caption that was super helpful that I'm going to put that into my labeled drawing. So if you want to pause your video to get caught up, you may. But I'm going to draw that picture. And they mentioned that there were stretched or squashed. Those were some of my examples. And here's my picture of my bowstring. So the bowstring here is my example. They're pulling it back. So I have some elastic. PE is potential energy. I'm kind of using some abbreviations. And it's a stretched example. So I put it right under the stretched. It mentioned in the caption that it transfers to an arrow as kinetic energy. And I know from before that's moving energy. So I put that in my notes so that I don't forget that for later. So there's how I included my drawing. I included examples and I have a definition. And I kind of spaced it out so that it's not all crammed onto one page. So when I go back to look at this, I have all of that information to look at. So you might want to pause your video, make sure that you also have this drawing, and make sure you also have these examples. And I'm going to then continue on. Now I need to take a look at, it mentions what causes elastic energy. So what causes elastic energy? I noticed that this right here is a really great key word. Headings can be key words. So I can put that off to the side in my Cornell notes. And it starts mentioning a force acting on an object can cause it to temporarily change its shape. Such as, so again, there's my example. I have an elastic band or a squishy ball with my hand. So they gave me two examples right away, so I would probably put those in as examples. When this happens, elastic energy can be stored in the object ready to be released when the object goes back to its original shape, when you let the elastic band go or loosen your grip on the squishy ball. Okay? So I'm going to continue on. I don't have this picture just yet. I'm going to try to figure out what is important in this into my notes. So again, I continue on and I put down causes of elastic energy. And that paragraph mentioned a couple examples. So right away, I'm going to put examples right there. So that's kind of my Cornell notes, how I go about doing that. And the causes of elastic energy, it mentioned that there was a force. Now, they showed me that the hand was kind of doing that, but the force is acting on an object. It can cause it to temporarily change its shape. So they showed me some examples. They mentioned some, but a picture might be helpful. But right away, they mentioned an elastic band is stretched. That is definitely changing its shape. And they mentioned a squishy ball getting squashed by your hand. I could picture that getting squashed by my hand, and that would definitely change its shape. So right away, I have a couple examples of the causes of elastic energy. And notice that I'm leaving a lot of space so that when I go back, it's easy for me to find that information as well. So you can pause if you need to get caught up. I'm going to continue on then to where it mentions that it says, where is elastic energy stored? So I'm going to continue on to where is elastic energy stored. That again is what I'm going to put as my key word on the side of my Cornell notes. It mentions that elastic energy is stored in the bonds between atoms. Now I already have that knowledge of what a bond is between the atoms, and I already drew myself that visual that I already have. These bonds absorb the energy as they're stressed and release the energy as they relax. It's kind of like a coiled spring, and then they show me a coiled spring. This is a great opportunity for me to draw this picture out, but I don't just draw a coil. I draw it compressed like they mentioned. I draw it stretched like they mentioned. And then I might even put the information where it talks about releasing energy as they relax. I might put that as my important information when I'm labeling the drawing. So it doesn't always have to be in a paragraph form. I can put the drawing and then label some of this information onto my drawing. So I'm going to go ahead and do that right now. So again, I'm continuing on. You might have to start another page, and that's okay. I'm putting a lot of spaces in between, so it's easier for me to find the information. So I'm going to go back to my Cornell notes here, and I have, where is elastic energy stored? That's an important heading. And then they gave me some examples. So again, I'm going to put that it is stored in bonds between atoms. That's where it's stored. I did draw my pictures right here again, but again, I had it on my other drawing, so that's okay. They mentioned an example, so I'm going to draw my example. They said a coiled spring. Notice again, I am labeling my drawing. I'm not just drawing the spring. So I draw the spring. They mentioned it was static. It was not compressed. It's not stretched. It's just kind of sitting there. This one is compressed. I write down the captions. And then instead of necessarily putting the information that was in the paragraph up here, like I was mentioning, I'm actually going to label it down here. So I notice that this is compressed and stressed, and they mentioned that that's absorbing energy. So instead of putting it up here in my notes, I thought it would be easier for me to put it down here. So you don't have to write this and cross it out. I just wanted to show you that sometimes it's helpful to put it right into your drawing as opposed to just writing it out in paragraph form. Then I noticed that they mentioned that it was stretched out. And when it's stretched out, it's releasing the energy because it's all relaxed. So again, I didn't put that information. I included that in my picture. I'm trying to make the connections between the pictures.
If you were in the building, would you please come to the front office?
Sorry.
Taylor Gordon to the front office.
So I'm continuing on with my reading. If you need to pause it and get caught up, please do so. So I'm going to continue on, and then they start getting into some really good examples. And some of you mentioning that you weren't like greatest artist. That's okay. We're just kind of sketching this. These notes are for you, so you're not showing someone else your artwork. And you might write sometimes the words, and other times you might actually draw it out. So a coil and a spring is pretty easy to draw, but this picture of an elastic band is not so easy to draw, so I might just write that one out. So I can put what are some examples of elastic energy. Besides these pictures, they mention that there's things like a squishy ball, a bow and arrow, catapults, and slingshots. They did not include all those pictures, but I might include all those as my examples. So I'm going to go back again and look for the spot where it says more examples. Notice I'm leaving a space again right here so that it's not too crammed in my information. And I'm just going to draw. The coil and spring was easy enough. The slingshot was easy enough. The catapults, that might be harder for you to draw. The elastic band, the sponge. They mentioned some of the other ones that I've already drawn, like the bowstring, so I already have that. Then where do I get some like captions or some informations? Well, it mentions the more an elastic band stretches, the more elastic potential energy exists. When I look back, some of you are wondering, I didn't see that in the reading. And so I'm going to show you where I got that information in the reading. So I didn't see any of that information here. I did not see any information here. I kind of looked back down and I noticed that they had an example of like a bungee jumper down here. And I thought, I'm not going to draw that bungee jumper, but this right here is pretty important, this information. The more an elastic band stretches. And I just wrote down elastic band. So it kind of fit where it says an elastic band stretches.
Or the Brinkman girls, please come to the front office. Kyle and the Brinkman girls, please come to the front office. Thank you.
Sorry about that. So it says the more an elastic band stretches, the more elastic potential energy exists. So I'm going to take a look. Oh yeah, I wrote down elastic band, so I kind of put that information right there. It just made sense to put it right there. So I'm going to continue on where it says, what do you mean? Now I'm probably not going to include that as my keyword, but I see that they have some definitions and they're bolded. Many times in science articles, they bold definitions, and those are usually pretty important words that you want to include. So I'm going to look through and says elastic energy. It looks like this is a definition. Looks like this is a definition. And then another example that I can put with the caption and some cool facts. Many science articles put those cool facts in there to help the reader understand or make a connection to their own life. And right here, they're doing that. It's stretching a muscle. We can all stretch a muscle, compress a muscle, stretch it, relax it, just like you're changing the shape of all of these other things. You're changing the shape of your muscle as well. So I'm going to continue on and try to write down the definition of elastic energy and potential energy. So I'm going to move on. Again, if you need to pause your video at any time, go ahead and do that. So I'm going to write down in my notes potential energy, and I might even abbreviate it as PE. And then the definition. It mentioned that it was stored in an object or a substance. Very simple. They mentioned that already in the article. They mentioned that elastic energy is a form of potential energy. Sometimes we call it elastic potential energy. So I got that from those two paragraphs. I didn't write everything down that they mentioned, but I kind of summarized that in a definition for myself. And then there was that wonderful drawing of the squashed ball. So they talked about that there was a compressed, kind of squishy ball. So I tried my best with my drawing. And I have example and drawing. So here is my rubber ball under stress. And remember those atoms that they mentioned? It's compressed and it's squashed and it's changing the shape. So when I draw it, I see that I'm actually having to change the shape, which is exactly what you want to do, is to draw that so you see, oh yeah, I had to change the shape of that, which is exactly what this article is talking all about. When you release that, it goes back to its original shape. So if you need to pause this and get caught up, please do so. Okay. I am going to mention there is that relaxed muscle and there was a stretched muscle or kind of a tight muscle. It really relates to the example of the squishy ball. Okay, so here's a squishy ball relaxed. My muscle is relaxed. Here's a squishy ball compressed. I might tighten my muscle and compress that as well. So if you need to pause it, go ahead and pause it and get caught up. But I should have all of this in your notes, these pictures as well. So I'm going to continue on and I'm going to take a look. And this article, luckily, has a nice summary for myself. It might not always have a summary. And this is where it's easy to go back and look at your notes and say, oh, yeah, I mentioned this example, and I can now come up with a summary. This one did a nice job including a summary. It says elastic energy is energy stored in object when they are under temporary strain. So when I was squishing that squishy ball, or when I was pulling back that arrow, or was flexing my muscle, it's temporarily that strain or that shape. And it might be stretched or squashed. The energy is then released when the object returns to its original shape. That was a really important part of this article. It's all about the shape and how it's getting compressed or stretched. And then when it goes back to its original shape, it's releasing that energy. So I'm going to continue and put that summary. So I always draw a line underneath. I put my summary. I don't have to write everything that was in that summary. I kind of look over and I try to figure out what was important. I know that when it was returning to its original shape, that was really important for that. So I write that for my summary. I'm going to have you pause it, make sure that you have all of that information on there, and then unpause it again, because I wanted to show you what some students are doing for a resource. And I want you to see what is going to be most helpful to you to understand the concepts. And when you're taking a content assessment and you have all these examples, because most of them are not just definitions, there's going to be a situation or it's going to be an example, and it's going to ask you to apply what you already know to that example. You can go back and look at some of these examples and say, oh, that was very similar to this example in my article. So here's what I'm seeing quite a lot of. I'm seeing a lot of this. So this was someone else who did this elastic energy article. I just kind of copied so you wouldn't see who it was. They put down Cornell notes, right? So here they have elastic energy. They have a definition somewhere in there. They have potential energy, just like we had, and they have a summary. So when I go and look at their notes, or when I go back and look at their notes have very similar information because we read the same article, but it's harder to pick out their examples. It's harder to understand what they meant when they say the bonds absorb energy and they mention atoms. They didn't go and explain that. They didn't go beyond and draw me pictures so that I can look. And they don't have all of the information we just did. So I want you to take a look at this and I want you to see. This is very challenging to read through and search for, like, oh, where was that example again about elastic energy? Oh, there it was, coiled spring or squash ball. As opposed to when I look here at mine, I have an example. The drawing just pops out. It's labeled. I can see a cause. I can see some examples right off the bat. I can see the example of when it's compressed and stretched. Those words just kind of like pop off of the page because I gave myself space and I gave myself some other examples. And it's easy to pick out those visuals instead of reading all of that information. And I continue on and I see that, wow, I had drawings, I had examples. This is how I would like you to take notes as a scientist. is I want you to include the drawings and I want you to include the examples. That's why they're on the resources for you, not for you to just skim over and think, oh, they just added that drawing to make it visually appealing. There's a reason that they put that stretched bow. There's a reason that they put that catapult. There's a reason that they put that slingshot. And captions are really crucial. Explanations and labeling of your drawing. But overall, I could easily give these to someone and they could probably not even read the article and understand a lot about elastic energy from just my information and my drawings and my explanations and my labels, as opposed to if I just hand them this and say, do you understand elastic energy? They might read this and go, I don't know what bonds between atoms are. But here I drew a picture of my atoms and the energies and the bonds. They might not have the best understanding, but it's much better than just reading through that information. Okay? So I would like for you to go ahead and look at another science resource in the energy power focus area. And do not want your notes to look like this. I still want the Cornell, but we're going to have definitions. Now we're going to have examples. Now we're going to have drawings. We're going to have labels. Some of the headings can be the key words so that when I look through your notes, you have a better understanding of the concepts. And if you don't, you're going to say, I don't know what this is. I'm going to look it up, or I'm going to ask the teacher. I'm going to try to find out some of the understanding before I just write it down into my notebook. But headings are important. And then obviously we're trying to come up with that summary. But I have definitions. That's what I would like for you to do on your own for the next resource and the next resource and the next resource. Be prepared for someone to say, oh, you don't have an example here. Oh, you don't have a drawing here. Now, I'm not saying that every science article has one of those, but many of them will have some type of drawing or diagram or photograph with a caption for you. You need to read those and make sure that you're including those in your science notes. Go ahead now and take out a piece of paper, open up an energy resource. Even if it's a video, you can pause the video. You can draw those those pictures that they're showing you, those diagrams that they're showing you. You can pause it and include those in your notes.